So this is a question from IIT JEE PYQ. The question is from the chapter Newton laws of motion from the year Advanced 1984. Advanced 1984. Okay. So here is the question. The two pulley arrangements shown in the figure are identical. The mass of the rope is negligible. In case A, the mass M is lifted by attaching a 2m mass on the other end of the rope. Like this is our case A. And in case B, mass M is being lifted by pulling this rope with a force that is equal to 2mg. Then we have to tell the ratio of the acceleration in the two cases will be what. Okay. So for first case, I will be solving for first case. Here is our case number A. Let me draw the FBD of both these blocks of mass M and 2m. So first I will draw the free body diagram for this mass M. So one will be a force acting downward due to the gravitational pull, that is mg, and one force is acting upward, that is due to extension in the string, that is called tension in the string. Okay. Let us suppose this mass is moving with an acceleration a in the upward direction. Let us suppose this is our acceleration a1 for this case A. So writing the equation of motion for this block of mass M, that T minus mg, that will be equal to m into a1. Okay. Now let me draw the free body diagram for this mass 2m. This is our mass 2m. Let us suppose it is moving downward with an acceleration a, and here will be a downward force 2mg acting on it, and one will be a tension force, that is called pulling force in the string. Okay. Now writing the equation of motion for this body, that will be 2mg minus tension, that will be equal to 2m into a1. This acceleration will be same for both the blocks in case A, so that I will be writing a1. Now let us suppose this was the equation number 1 and this is our equation number 2 in case A. Now adding up these two equations, adding equation number 1 and 2, will be getting the equation number 1 is T minus mg is equal to m into a1, and equation number 2 is 2mg minus T is equal to 2m into a1. Okay. So here by adding these two equations, tension will be cancelled out, and we will be writing 2mg minus mg will be equal to mg, that will be equal to 2ma1 plus ma1, that will be equal to 3ma1. Here m will be cancelled out and acceleration a1 will be equal to g by 3. Okay, so this is our acceleration in our case A. Now let us consider the case B here. This is our case B. So case B is what? We are pulling this string with a force of 2mg. So there will be a tension developed in the string that is equal to 2mg only. Okay. So here we already know that the tension in the string is equal to 2mg. So I will be drawing the free body diagram for this body, that is equal to m. This body is of mass m is there. There will be a force acting in downward direction, that is equal to mg, and tension in the upward direction due to the pulling force of this string, and let us suppose it is moving in upward direction with an acceleration a2, that we have to find here. Now let me write the equation of motion for this particle, that is equal to T minus mg is equal to m into a2. So here value of T we already know, we have calculated here 2mg minus mg, that will be equal to m into a2. So here m will be cancelled out on the both sides. So our acceleration a2 will be equal to 2g minus g, that is equal to g only. Okay. So what we have to find here, the acceleration ratio of acceleration in two cases. So now we directly write the acceleration a1 by a2, that will be equal to our a1 was g by 3, that is g by 3 divided by a2 is g, so that will be equal to 1 by 3. So ratio of acceleration in two cases will be equal to 1 by 3. Okay.